afternoon, everyone. I'm Martin Andres,
And I am Vincent Ramos, and
and
we
we are
are
your
your
anchors
anchors
in
in
LUPAENG
LUPAENG Network.
Network.
This channel focuses on featuring renowned geotechnical engineering incidents, giving you insights on its problems through thorough analysis.
And proposing possible solutions based on our learnings in our course CEGEOEN. Prior knowledge and the concepts discussed will be necessary to fully understand the report. Nicol Highway is a 759 meters long highway located in the eastern area of Singapore. This was constructed to lessen the traffic in Kalang and Geylang roads. The site of construction was said to be a reclaimed area 40 years before its construction, wherein a 3-meter to 5-meter thick of sand was placed over a 30-meter shallow seabed made out of soft to very soft marine clay. However, it was reported that the consolidation during the reclamation was not yet completed and still has a residual for water pressure. Years later, a new cotton cover underground tunnel was constructed for the Circle MRT line, included the deep excavation of soil for basements and building water distribution networks. The construction was located just beside the Nicol Highway, and concrete diaphragm walls were built along with the installation of steel struts for additional support against lateral earth pressures.
On the collapse, the researchers that studied the incident had some interesting observations. The first one is a problem with the connection between the struts and the whalers were identified. This resulted to retrofittings. Next, the quality of the basis of the design, the temporary lateral earth support systems were questioned. Lastly, experts from the Land Transportation Authority claimed that the computer programs were incorrectly used, which led to miscalculations in the bending moments and deflections of the walling. This is the picture before the collapse, and this is after the collapse. This is the location of the collapse. This is Nicol Highway, and this area is the construction part. Deep excavation, like the one done under the Nicol Highway to construct the MRT, can result in soil deformations, which can lead to unwanted effects upon the nearby structures if proper support systems are not installed. These effects are mostly related to different geotechnical components or properties. The method of the analysis will focus on identifying the problems that caused the collapse of the highway. This will cover soil failure, shear and axial forces, strains, possible heaving effects, ground settlement, and lack of sufficient support. To provide you with an overview on the whens and hows of the collapse, here is our reporter Machen Lim with the inside scoop. Machen.
Thank you, Vincent. The Nicol Highway is located in the southern coast of the Singapore island as shown in the figure, and it's particularly located in CA24. And the 2-kilometer span of the route comprises the construction of the Nicol Highway, the boulevard stations, and all other linking tunnels. February 23, 2004, measured lateral wall deflections exceeded the design level, so 2 back analyses were conducted in the span of a month to increase the measured lateral wall deflection from 145 millimeters to 253 millimeters, and lastly, 359 millimeters in April 19, 2004, the day before the collapse. In April 20, 2004 at 11 a.m., the drop at the 9th level strut increased the load at the 8th level strut via load transfer. And at 3 to 3:30 p.m., people were told to evacuate due to failure at the 8th level strut, causing collapse at exactly 3:30 p.m. And approximately 80-meter long diaphragm walls converged to meet each other post-collapse, accompanied with an adjacent subsidence of 13 meters and a visible settlement extended to a radius of about 50 meters. The structure is believed to be embedded in old alluvium, particularly its diaphragm walls. And old alluvium is considered as weakly bonded sandstone that is weathered at the top to a dense sandy soil. That is why it has a soft upper marine clay layer overlying a stiffer lower marine clay layer. But in comparison to the results from the original geotechnical interpretative memorandum, it showed that the lower marine clay layers have a weaker strength compared to what was originally planned. So it's deemed that there was under consolidation in the lower layers. Also, old alluvium has low permeability and low recharge potential. The conceived causes of failure are firstly the under-designing of the diaphragm walls with the use of effective stress parameters as inputs instead of total stress parameters that are believed to be more reliable in predicting how levels of strut have the capacity to withstand loads. Secondly is the replacement of strut waller connections by the C-channels, which are not really the conventional plate stiffeners to be used. And lastly, also the misuse of the computer programs that led to an 18% overestimate of the strength of what is expected in overly consolidated clay, as well as the 4% underestimate of the lateral force on the earth wall. Gas, water, and electrical cable snaps led to power outages experienced by roughly 15,000 people and 700 businesses in the Marina area and Suntec City. Tremors were felt by the tenants and residents nearby the gold mine, hence they evacuated. And the police cordoned off the Merdeka Bridge, as well as all the roads that led to the Nicole Highway, which affected mobility for thousands of commuters. This geotechnical accident generated millions of dollars of damage costs, and the Nicole Highway reopened in December 2004. To further expound on the causes of the collapse, we have Engineer Benher Ocampo and Engineer Tomas Santos, both geotechnical engineers, to deliver the analysis on the site of the collapse.
So one of the sources of the collapse is most likely the excess amount of force and pressure experienced on the supports. One of these supports is a diaphragm wall, which are highly affected by the depth and speed of excavation which was happening there. It cannot handle the change, most likely leading it to deflect under the pressure. Other options provide a fair amount of stability during these excavations and provide other benefits to the structure as well. One of these other structures would have been a secant pile wall. They're commonly used in deep excavations like basement walls and installments of underground train systems. It utilized the installment of two sets of piles, and the second set mainly being used to reinforce the wall strength. So of course, there's advantages to this. First is that because of its strength, there will be a minimal amount of deformation and deflection experienced in it. Second, due to the tightness of it, there will be water tightness, preventing any water flow through the walls or damages to it. Next would be the flexibility. It'll obviously not immediately rupture or crack under these pressures. But understanding this, there will of course be disadvantages to it. The first one is the limitation in real life factors. Secant pile wall installments do not consider factors like the uncertainty of drilling and the changes of shape or unstraightness of it. It also takes a lot of time to install these two pile sets, since of course you have to first install the first set, then wait for it to somewhat dry, then install the second set. This would require a lot of time and space. And understanding since there are multiple piles, it'll consume a lot of money. These recommendations would have helped prevent the collapse most likely or mitigate the time to prevent any deaths or casualties in it. Now my colleague, Engineer Ben here, will take the floor to discuss the idea of the miscalculations that happened and the factor of safeties that must be considered.
So thank you, Thomas, for that wonderful explanation. So for the analysis and discussion about the failure of the struts due to overloading, let's start with the structural support system. This is the key element in any design of deep excavation, particularly in difficult ground condition. Multiple layers of the struts are the critical factor, especially in deep excavation. So these are the critical factors, the struts, because it carries the loads laterally and vertically. Maybe it will come from the soil layers or the highway materials itself. So the overall failure will generally take place if a complete strutting level fails. So what went wrong in this Nicole Highway? The engineers failed to assess the lifespan of the C-channel struts that is used in the highway. The struts that are used both failed laterally and vertically. So as I've said earlier, the structural support system carries the loads laterally and vertically. So if the struts failed, then the whole structure, the whole system will also fail. The common solution here is the 3D analysis, as it covers all cases of wall stiffness, property of soil layers, friction between retaining wall panels, and soil arching effect due to deflection. But this solution will take so much time, and the 2D plane strain analysis or 2D strut analysis is recommended to be used. So the concept behind it is to remove the whole layer of failing strut, thus will provide paths to distribute the forces in the vertical direction caused by the soil. Two-dimensional analysis will take less time, thus will produce faster results for the trial and error process and will allow accurate calculation to be in line with the time frame of the reconstruction of the said failed strut. So that's all. Thank you. Back to you, Marian and Vincent.
Who would have known that the stability and suitability of the soil where the buildings are built upon are just as important as the structural integrity of the building itself?
From the main support, I can say that geotechnical failure of a structure does not only destroy itself, but it may also affect the other structures around it. That's why engineers must ensure that in-depth calculations and analysis were done considering the presence of surrounding structures to not miss any specific details and possible failures that could occur.
It is important that engineers and contractors assure the safety and the robustness of structures to withstand different loading conditions to prevent failure, especially in large-scale projects such as this one.
These problems and situations are not minor mistakes that affect just a single structure, but rather can alter the ground and plans of our city. It is essential that engineers take every step to ensure the safety and well-being are fully considered when designing and constructing structures in order to prevent these accidents from happening again.
Failure of even a small part of the system will compromise the safety of the whole structure. With that being said, I've learned that computation, material, soil and land profiles are all crucial in constructing a building, highway, or bridge. It demands time and perfection from the engineers down to the workers to assure that failure on the structure is not possible. Thus, will provide safety for the people that will be using your completed infrastructure.
What great insights by our professionals today.
This
This
is
has been the
LUPAENG
LUPAENG
Network,
Network, wishing you all a good day.